Hi, everyone. I'm Nicole Burdett with Meritalk. Welcome back for what I know will be two fantastic sessions. Up first is Accelerating AI Time to Value with HPE and Red Hat. I'm happy to introduce our speaker, Shep Bostin, who is Enterprise Architect at HPE. Shep, over to you.
Thank you very much. And there we go. So I'll hit my slide. So it's a little bit of bait and switch because Red Hat is involved in this solution, but what I'm going to talk a lot about is retrieval augmented generation, because Red Hat is part of a bigger picture of solutions that we're going to talk through here. And I'm looking at you people in the back. No funny business, no paper airplanes or anything. I can see everyone. So this is just our confidential disclosure agreement. It just means I may talk about some products, some concepts and things here, subject to change without notice, et cetera, et cetera. This is the only marketing slide in here, I promise. Just motherhood and apple pie. AI is changing the world. I don't need to tell anyone in this room. So we're going to start with a little foundational education. And please wave if you have a question, because it is hard to see with the lights in my face, because I'm happy to answer questions along the way. But let's start with a foundation of different kinds of AI models so we know what we're talking about. The most basic kind are reactive or decision support systems. This is the most primitive stuff you've been using for a long time. We'll hit some examples in a second. The second type is narrow or weak AI. AI that does very specific tasks that gradually produces better and better results. The third is really strong AI. This is where it does really powerful intellectual tasks. And this is where you start hearing large language models. We'll talk more about that in a second. And then finally, artificial superintelligence, the thing that we all think everybody's working on, where it surpasses the capacities of humans to do all kinds of things. So examples of these different categories, in the easy circumstance, smart appliances, simple computer games, the spam filter that we've had in Outlook for years, that's the most simple type of AI. The weak AI would be more of the everyday AI that you don't think about as being AI, but certainly is. So if you have, it's so funny, I can't even say her name out loud because I'm worried she'll answer. Alexa in your house, or you've got one of those OK Google devices, even ChatGPT itself, in its most basic form, it's kind of weak AI. And some domain-specific systems. IBM is here talking about Watson, AlphaGo. These are good systems, but they're very narrow in their focus. Stronger AI is autonomous driving, which is almost there, but still not quite. ChatGPT in its current incarnation with GPT-4 and beyond. Some of the autonomous UAV, UUV types of devices that I'm sure they've been talking about in some of the sessions here. And then superintelligence. Legal made me take out the picture of the Terminator that I had here, but you get the idea. HAL 9000, the Terminator, those kinds of things. So these are the categories. What we're focused on in a lot of our day-to-day work is right smack dab in the middle. And the big focus today, and what I'm going to spend more time on, is what can we do in this realm of stronger AI that is actually doable today and isn't going to cost the budget of a small country. So let's start with, what are large language models? Many of you have probably heard this term. These are models that have been trained to understand, explain, and generate text content based on massive amounts of other text content. And their architectures use layers of billions, or in the case of the latest GPT-4 behind ChatGPT, almost 2 trillion parameters that are used in order to give an answer, which is amazing. But there's an important little note here in the corner. Model performance is not increasing as these models get bigger. And when I say performance, I'm not talking about how fast they are. We can throw hardware at this problem. I'm talking about how well they do, because all they're doing is guessing what's the most likely next word. If I stand here and say, Mary had a little, every one of you just thought lamb in your head. Maybe one out there has weird, like, she had a little hat. I don't know. But most of you just thought lamb. That's all that these large language models are doing, is getting really good at predicting the next word, phrase, sentence. Separate from that, What is generative AI? Generative AI uses models, it could be text, could be images, could be video, that just have huge amounts of content that they're trained on. But this is the important point. They're revolutionary because they create new content that never existed before. That's a big distinguishing factor of this side of the equation versus large language models only know what they read. Maybe they read the whole internet, so they know a lot, like ChatGPT, but they don't make something that never existed before. When you merge together generative AI and large language models, you can get things like this. Write a poem to my boss asking for a raise in the style of Edgar Allan Poe. I did this when I was putting the presentation together, and I think it did a pretty credible job. I think they're going to give you guys all copies of the slides later, so feel free to bring this to your next review. It also does visual things. So I could say, give me a 3D rendering of a cute tropical fish against a dark background, blah, blah, blah. Boom, there you go. I did one once with my dog in a spacesuit floating around the moon. Boom, it gives me a nice picture. This is fun. This is cool. This takes enormous amounts of hardware. How do we make this more useful? With generative AI, what we saw with ChatGPT, the thing that every one of us has heard of, every newspaper headline has been written about. ChatGPT went from 0 to 1 million users faster than any system ever. Faster than Instagram, faster than Spotify, certainly faster than Facebook and all the rest. 5 days to 1 million users. As of April of this year, I need to update and find out what the new number is. But as of April, they had 180 million users of ChatGPT, which 2 years ago or so, most of us had never heard of. But there are challenges to getting started on an AI journey if you want to produce useful systems based on all of this technology. The first is, if you've ever looked into it, there's an enormous range of tools, generally open source, very limited support. It's kind of like how Red Hat started 30 odd years ago, but they grew up, they got support, things like that. That's why we're talking about solutions like this today. The range of tools today is astounding. All of these logos, all of these different tools, how do you make a decision? Except I'm playing a game with you right now. This is the 2014 chart. This is the chart today. How can you possibly sift through all of this information, all of this growth, and know what are the right tools to use, what are the right techniques to use to create AI systems that are of value? So that's a challenge. Second is, lots of coding is often required. A lot of the tools are still kind of old school, got to learn the scripting, got to use a little Python. Maybe you can automate some things with Ansible, but you've got some limitations. Hand in hand with that is there's a shortage of expertise. Any of you who've been trying to build AI centers of excellence in your organizations, you say, all we need to do is go hire a data scientist. How's that? That's like trying to buy a house right now. It's a real competition, a bidding war. Accuracy of large language models also varies greatly when applied to specific domain use cases. This is important. If you've ever used something like a ChatGPT and you tell it to do something cute like I did, like write a little poem for you, great. Ask it to tell you something really specific. It's hit or miss as to whether it understands. It certainly doesn't understand the jargon of our business, all the acronyms that are specific to a DoD domain or an intelligence community domain versus other domains that you may work with. They also hallucinate. Those are the fun things you've heard headlines about. All of a sudden, ChatGPT told me to leave my wife. Like weird stuff. Because it's just a large language model. It's just predicting the next word in order. Also near and dear to our hearts, I think most of us in this room, is there's very limited protection for your data. I work for a company, like many of you probably do, that says, hey, none of our stuff gets put into public Gen AI systems. None, zero. no code help, no cheating on your paper. Nothing goes into those public AI systems because we don't know where that data goes. And there's no protection if we have intellectual property. You also need to have very high-end hardware to build robust general-purpose LLMs. The stats I put in here are for the original ChatGPT build, and it took 300,000 CPU cores and 10,000 GPUs. You're not going to do this from scratch yourself. It's already been done, and there's multiple companies doing it, but it's a barrier that's too high to get around. So how do we solve this problem? The solution I submit to you is something called Retrieval Augmented Generation, or RAG. What is RAG? It combines the LLM capabilities that we've talked about with some of the Gen AI capabilities that we've talked about to give relevant, timely, accurate answers to the questions that you pose to it. Now, how does it do that? In a normal interaction with a large language model, you put in a prompt, write a poem, blah, blah, blah. It hits the large language model, and it gives you a response. That's it. In a RAG system, you enter a prompt that is really like a query. It goes into what's called a RAG module. The output of that RAG module is then fed to a large language model, which then formats the response for your use. Now, what's inside that RAG module? Two main components are inside the RAG module. There's a knowledge base, which is typically in the form of a vector database. You don't need to know too much detail on that. You'll get a sense of what's in a vector database in a minute. And a retriever, the thing that translates the query into a format that can be used against the vector database to give you the results. So the generated response from the model is augmented with the data that is retrieved from the vector database. Retrieval, augmented generation. That's where all of that comes from. Everyone with me so far? See good nods. Excellent. So how does this actually work in practice? You take your documents. Today it's all documents, I will say. Other formats of data coming soon to a theater near you. Right now it's document-centric, which is okay. We got a few documents in this room, I'm guessing. They are loaded or scanned into the system, which can sometimes do pre-processing if you need to normalize formatting and whatnot, but you load your documents, PDFs, Word files, text files, RTFs, Markdown, you name it, into the system. The documents are then broken into chunks. Might be phrases, paragraphs, sometimes words, depends a little bit. It's a nuance, but they're broken into chunks. Those chunks are then translated into numeric values, almost like coordinates. And these values are embeddings. They're vector math values. They're called embeddings. So you get chunks and then embeddings, and then that is what is stored in the vector database along with the original source documentation. So then when you have a query, write a poem for me, or maybe more appropriately, which regulations within the FAR would apply to this acquisition that I'm about to do? It takes that query, translates the query using vector math, and then it uses that to match what's in the database. So you can see now it's a math equation. The database has lots of vectors. My query is now a vector. Which are the results in that database that are closest to what I'm asking for in my query, and then uses the large language model to spit the result out in a format that I can understand with citations to the source documents. So you know where did it get the answer, which is a big difference from just A large language model like a ChatGPT, you don't know if it made it up. You don't know if it stole it. You don't know if the data source is valid. This is your data. So you control whether the data is valid. Here's a simple example of RAG. And what we did to build this simple database is we loaded a variety of documents into a vector database that were related to world destinations, world facts, almanac types of stuff. In this case, we used an open source vector database. There's detail up there. You can get it when you get a copy of the slides. And then we gave it a prompt. In this case, now when we wrote this, Lebanon was a little more hospitable than it is right now. But we said, hey, I'm an American traveling to Lebanon soon. What should I be aware of? Give me your top 3 answers in a bullet point list. So we had our query prompt in the upper left corner. The response was a combination of the generated bullet list in the upper right corner and, importantly, citations to the specific documents that were the sources of that information. Think about applications in your own organization where I want to ask a question and I want to get an answer. I want to know what the source is. I'll give you an example. We just completed one of the first production ones we've done like this. It was for a law enforcement entity, police department, and they are using a system like this to write warrants. What could be more boring to the average person than the writing of a warrant? But if a law enforcement officer is spending hours, in some cases, constructing a warrant with proper citations to the law so that a judge will sign off on it, and then they can go and actually execute the warrant and do the work that they signed up to do, if I can change those hours to an average of 15 to 20 minutes, which we did, what is the impact on how efficient and effective those law enforcement personnel are from something as simple as writing warrants? One other thing to point out on this slide, which I forgot the last time I presented this, you'll see a slider up there that says temperature. Temperature has to do with accuracy. It's a little bit of a term of art in a RAG implementation because it has to do with how wide of a net am I going to cast for matching results. Now, you might think, well, push that temperature slider all the way to 0. I only want accurate results. Well, sometimes you get no results if you do that. You also get unexpected results if you do that. I played with a system like this. It happened to be a voice synthesizer system. I thought it would be fun to make a video of our CEO saying something nice about me and what an expert I am in AI and putting that at the front of a presentation. And there's plenty of video of our CEO out there on the internet. So I put it all into a system and I said, there, give me a video like this. And now you may not know, our CEO is an amazing dude, born in South America, spent some of his formative years in Italy, started working for HPE in Amsterdam. I mean, so his accent is very unique because he speaks so many different languages. When I put this all into the system and it cranked out a quote for me, guess what happened? The accent disappeared. Because accents are a form of inaccuracy. So sometimes you need to tweak those temperature sliders to get a result at all, even though it means you're not necessarily going to get the perfect result. Sometimes you will, but sometimes you won't. So the obvious question now is, how do I get started with this? So our recommendation is something we call the Gen AI Starter Kit. And there's an important little fine print down there, which is kind of a plus-minus type thing, right? This is not an official product. There's a few guys like me in our company who said we need something like this, and we can't wait for the company to put it together officially. So we want to take a set of shipping products, assemble a recommended architecture that will compress the time to value, which is in the title of this talk, so that customers can get ROI on AI quickly. And that's our goal. First step, it's in bold for a reason. Most important thing if you're getting started with an AI project, pick something well-defined and preferably pick something you already measure. Predictive maintenance. You know in predictive maintenance how long it takes you from being given a problem to figuring out what are the pieces, parts, steps, instructions you will need to resolving the problem. Same with customer support. Same with the warrant example I brought up. If you know how long or how much effort or how much cost was involved in doing things before, you can measure the impact of the AI so that you can go to whoever hands you the money for this project and say, look what we were able to accomplish, and move on to the next project and the next project and the next project. Now, our particular approach, not surprising with the logo on my shirt, involves some Hewlett-Packard Enterprise server hardware, NVIDIA GPUs, Red Hat operating system and container platform OpenShift, as well as some AI software from us and from NVIDIA to construct a platform that allows you to develop and deploy a retrieval augmented generation system. This is not a whole rack full of gear. This is not 10,000 GPUs. We do kind of force you, because it's not an official product, I can make you do anything I want. So the three of us that decided this should be a thing said we will only sell it with at least a week of consulting. It takes us a few hours to stand up the system, and the rest of the time is to make sure that this first project goes perfectly. You can bet that when we did that law enforcement example and we sat with them for 2 weeks and made it work, then they really got it, they internalized it, and now they're ready to go do the next project and the next project and the next project. Now, if you want to push this out to other locations, you can certainly scale it up. More of the big nodes. We have, in our case, we have some edge products, our Edgeline EL8000, our new DL145, which is a highly tolerant edge server. Both of those work up to 55 degrees C. They're small, but very powerful platforms. So those are perfect as a complement to this. And they're not particularly expensive either. The basic Gen AI starter kit with a week of services is under $200K. Not millions, under $200K to get started. And then you can always augment with those less expensive boxes for pushing it out to multiple locations if that applies in your situation. But the idea is to get started, do a project, get some return on your investment, and that provides, I think, the momentum, the justification, the confidence to do more projects beyond that. And so with that, came in with about 6 minutes left, so any questions? Yes, sir. Good question. So images today are not supported by production RAG systems. However, there is an expansion of the RAG concept, which is called multimodal RAG. So if you ever hear that term, what multimodal RAG is a system like this that returns results not just with text, but also could be images, could be video, could be links, other things besides straight up text. So I've already got a Navy customer where they're looking at putting in a system like this for condition-based maintenance, but they're already looking ahead to, this is great, but I also want the schematic, that kind of thing. So yes, that's coming in these systems and certainly will be an add-on that is able to be incorporated as more and more of these come online. Other questions? So the current iteration of this uses some HPE AI software that we have on the shelf to keep cost manageable. We do have reference architectures that include NVIDIA AI Essentials, NVAIE, or AI Enterprise, with our HPE AI Essentials. And certainly other Red Hat software could be in here. There's a partner of ours that was exhibiting with us at an event last week called Yurts, and they've got a production grade system, and that'll all work with this. The goal is really to give a starting point. You're right, we can meet people where they are. I will say, in my experience talking to customers all the time, there's a handful of folks out there who are pretty far down the road with this. 90% or more are like, we know we got to do something, but we don't know how to get started. And I can't go to my boss and ask for $1 million for a research project with no idea of how we're going to get a payoff. And that's been an obstacle in a lot of organizations, across the government. Yes, sir. Manage accounts, you mean in terms of login security? So there's a couple different ways that this gets handled out there in the world. One is that these platforms for developing these RAG systems have a concept of workspaces. So I have a pretty fancy computer on my desk. So I have an LLM system that I stood up on the computer. And one workspace is the one that I'll pull up on a Teams call and show customers how I can query against our HPE quick specs, and they get an idea of how RAG works. Another workspace is my personal data, which is stored in a whole range of document files that I have in the hard drive. So you can segment that way. There's also security login, so systems like Yurts, which I mentioned, NVIDIA AIE, Red Hat systems, they provide user logins with privileges so that you can segment the resources that people are accessing, which data they can access, and so forth. So that's a very fair question, and there's all different ways to handle that, depending on how rigid and rigorous the needs are. For some of the high side types of applications, which some of you may be involved in, the answer may be in part to have multiple of those central nodes so that we can segment out certain databases so they're not touching. But it really depends. That's where we get into the specifics, and that's what we're here to talk about with you. Other questions? Yes, sir. Very good. Rag to riches. That'll be the title of the next talk. And I'll make sure my kids are in the audience so they can groan as they always do at my dad jokes. So yes, that's very funny. We got a minute left. Time for one more question if there is one. All right, well, I'm staying after school. If anyone wants to have any side conversations, I'll hang out at the back for a few minutes. And I thank you for your attention today. Hope it was useful.